Evaluate recursive formulas for sequences. In the previous section, we talked about evaluating variable expressions for number sequences. Now, the word recursive means that we're going to need information in order to find the next piece. Then we're going to use that information to find the next piece. Then we're going to use that information to find the next piece. This isn't as simple as, oh, I want to know the fifth term in the list. So in a pattern of numbers, if I want to know what's in the fifth place, I can't just simply put in a 5 for n. I can't just substitute it in like I did on a regular sequence. Recursive sequences are dependent upon the answer that you previously got. So whenever you see something like this, you're going to end up having to kind of plug and play and then use that answer to plug and play into your next problem to find the next number in the sequence. So it uses the previous term that you just found for the next part. So you can see how it's highly dependent upon, I got to find this before I can do that. Let's go ahead and just take a look at some examples. If you wanted to find the second term and the third term, and you're already given the first term, which is 1, cool. Now here's how this is going to work out. You can see it looks a little bit different, and that little bit different section is right there. It's actually taking the term and subtracting 1 from it. So whatever place value it's in, so say the first place, and we subtract 1 from it, that would be the 0 place. This is why whenever you're reading these problems, it will say that n has to be greater than 1. So what we're going to do is we are going to find the second term. I'm going to show you how that works. So a second 6 times a 2 minus 1. So you can see that I'm working with the second term in the list, right? And you're going to see that this is going to, as we evaluate, 6a1. Oh, so 6a2 is going to use the answer from the first term, which is a1, our first term in the sequence. So whenever we're substituting this in now, it's going to be 6 times whatever the first term in the sequence was, which is 1. So A2 equals 6. We can repeat that process by using A2 to get A3. So if we wanted to find A3, that means we're now substituting a 3 in for the variable n. So 6A3 minus 1. You can see as we evaluate how this is going to keep on working out. 6A, now it's saying we're going to substitute in the second term, the answer of the second term, which was 6. Now we're going to substitute that in. A2 was 6. Now we know that the third term is going to be 36. And it makes sense that this is growing by a factor of 6 because whatever the term was is being multiplied by 6. And it just so happened that our first term was 6, so you can see how it's multiplying by itself, growing by 6. The same is going to hold true for the next one. We have to find A2 and A3, the second and third position in the sequence. The recursive formula is going to allow us to substitute a previous answer in. And all we have to do is go, all right, well, what am I looking for? I'm looking for A2. Cool, I'm looking for the second term. So that would be A2 minus 1 plus 3. And we're going to go through the same process. Yet again, we're going to evaluate. A2 minus 1 is 1 plus 3. So that means I'm taking the first term. Whatever A1 was, the first term in the recursive sequence, which was 10, you can see that right here. I'm going to substitute that in for the first term, A1. So that's going to be 10 plus 3. So A2, the second term in the list, is going to be 13. And this makes sense because whenever you're looking at the formula, it's going to be whatever the previous answer was plus 3. So I think you can make a prediction about what the next one's going to be, but let's go ahead and go through the motions. So A3, or the third term, is going to be A3 minus 1 plus 3. We evaluate. We get 3 minus 1 is 2 plus 3. This means we're going to be taking the second term, whatever the answer was for the second place in the sequence, and substitute it in for A subtext 2. You can see that is right there. A2 equals 13. So we're going to go 13 plus 3. And now we know that the third term in the list is going to be 16, which is probably what your educated guess was. Let's go ahead and take a look at the last one. Find A3. So this is where the recursive sequence comes in to play versus a regular sequence, is that whenever we're trying to find A3, I can't just jump to the third term. I have to find the second term and then use the second term to find the third term. So here we're going to go A2 minus 1 plus 13. So as we evaluate, you're going to see how this is going to tell you what you need to be putting into the formula. So I'm taking the first term, A1, which was 15, substituting it in for that. Now I know that A2 is going to be 28. Which makes sense also because you can see that it's going to be whatever the previous term was plus 13. So 15 plus 13 is 28. Let's go ahead and take a look at A3. So it's going to be A3 minus 1 plus 13. I'm just plugging and playing over and over. A3 equals the second term in the list plus 13. Our second term was 28. So A3 equals 28 plus 13. The third term in the list is going to be 3141. There we go, 41. So yet again, all we did was add 13.